the atmosphere. Section 1, atmosphere basics. The atmosphere is pretty important for us. It provides climate moderation, it absorbs radiation, transports and recycles water and nutrients. The atmosphere is 78% nitrogen, 21% oxygen, 1% other gases. There are 5 layers of the atmosphere that differ in temperature and composition as well. In terms of our 1% of other gases in the atmosphere, we have both permanent and variable gases. The permanent gases that make up the 1% of our atmosphere, the concentration never changes. Those permanent gases are not impacted by any human or weather phenomenon. Permanent gases include neon, helium, hydrogen, and xenon. We have variable gases also in our atmosphere. The key with the variable gases is the concentration of them does depend on human activity. Carbon dioxide, methane, ozone, chlorofluorocarbons are all of our variable gases. 5 layers of the atmosphere, starting with the Earth. We've got the troposphere first. Go ahead and put your arms out in a little T. You're making a lowercase t right now. Wave them around a bit. You are literally waving through the troposphere right now. Okay? So we're in the troposphere. It has the most dense concentrations of gases as well as all of our weather phenomenon. Stratosphere, moving away from the Earth, is our next layer. Stratosphere contains a higher concentration of ozone molecules, which absorb UVB radiation, prevent us from getting skin cancer. The mesosphere is next, away from the Earth, after the stratosphere. The mesosphere is pretty low air pressure, not a lot going on there. Thermosphere is next. The interesting thing about the thermosphere is the gases in the thermosphere react with incoming X-ray radiation from the sun to make the northern lights. So the northern lights take place within the thermosphere. And then the exosphere is our outermost layer, very, very diffuse gas concentrations, kind of the not really the boundary, but the kind of end of our atmosphere out into space. I do have a saying for you to help you remember from Earth to space the layers of the sun. The saying is, Texas students make tacos. Excelente. So troposphere, stratosphere, mesosphere, thermosphere, exosphere. Texas students make tacos. Excelente. Okay. Section 3, atmospheric properties. We have atmospheric pressure, which is literally the amount of gas above us. The pressure of the gas above us is atmospheric pressure. We have relative humidity, the amount of water vapor. We know what humidity feels like. So when we talk about pressure, we can have 2 types of weather systems with pressure. We can have a high pressure system, which really means we have extra molecules of gas above our location. Or we can have a low pressure system, which means we have fewer molecules of gas above our present geographic location and low pressure. When you have a high pressure system, generally air moves away from this high pressure system to equalize somewhere else, and you have fair weather. When you have a low pressure system, less gas molecules above your location, air will move in and generally bring clouds and precipitation. We have differences between air masses. The front is a boundary between 2 different temperature and density air masses. We also have something that's very important when we talk later about air pollution called a thermal inversion. Got a little diagram to help you out here. So if this is your city, that's your city down there. Here's my city, whoop, my city. You have warmer air around your ground, basically, and then you've got a cool layer of air above this warmer air. This cool layer of air is more dense. So as pollutants try to rise, the warmer, less dense air tries to rise and gets trapped by this cooler, more dense layer of air, and it concentrates your pollutants around the ground. So cold, dense air keeps whatever is released by your city, your smoke or whatever type of air pollutants are released, keeps it trapped down there. Okay, section 4, the greenhouse effect. So the sun sends out a type of energy called infrared radiation. Guys, here's a hint. Infrared radiation is heat. Heat is infrared radiation. Okay, so that's a term you're like, oh, infrared radiation. It's just heat. Okay, in any case, what happens is the sun, our friend the sun, will release heat, right? Infrared radiation. It will come through the clouds in our atmosphere and hit the Earth. Some of this infrared radiation is absorbed by the Earth. some of the infrared radiation bounces back into the atmosphere. Well, the atmosphere, the gases in the atmosphere are very good. They'll basically get hit with this infrared radiation, they'll vibrate, and they'll send it back down to Earth. This is the naturally occurring greenhouse effect. The gases in our atmosphere, and the diagram is a bit misleading. It's not the clouds in our atmosphere, it's just all of the gases in our atmosphere will trap heat and then re-radiate it down to Earth. Some gases in our atmosphere are much better at doing this than others. Carbon dioxide, methane are effective at trapping the heat and re-releasing it back to Earth. The naturally occurring greenhouse effect is very important for life on Earth. The temperature on the planet would be about 60 degrees colder than it would without it. So life on Earth is very much reliant on the naturally occurring greenhouse effect. When we increase, however, our concentrations of heat-trapping gases like carbon dioxide and methane, it's sort of like being comfortable in your bed and then adding 3 more blankets. Then you're not comfortable, you're trapping too much heat in your bed. The same thing is happening in the atmosphere. It's basically like adding some extra layers of blankets onto our Earth, keeping more heat in. That is actually causing some problems for us. Okay? There's one other term with the greenhouse effect that's very important. It's albedo. Albedo is reflectivity. So how much solar energy something reflects is called its albedo. White has higher albedo, higher heat reflectivity than black does. You know this, right? What is going to be a hotter car to get in the summer? A black car, right? Because black has lower reflectivity, lower albedo, and more heat is absorbed. A white car, much cooler. Why? Because white has higher albedo, higher reflectivity of that infrared radiation or heat that's coming in the summer. Okay? Last but not least is El Nino. El Nino is abbreviated ENSO, or El Nino Southern Oscillation. It's a shift in atmospheric pressure, as well as sea surface temperature and ocean circulation within the Pacific Ocean. What happens to trigger an El Nino? Air pressure increases in the western Pacific, and it stops the normal equatorial westerly flow, right? From 0 to 30 degrees, we've got our westerly winds flowing from east to west. Those westerly winds slow down and stop. And normally your water gets pushed more towards the western Pacific, the warmer surface water, which creates a kind of a conveyor belt system of currents, and that slows down and stops with El Nino. That messes with a lot of precipitation patterns around the world. It also impacts, surprisingly, fishing. It stops the cold water upwelling around South America, which normally will cause a lot of the cold water upwelling, brings nutrients up, which feeds the algae, which is the base of the food chain there. So El Nino is a atmospheric phenomenon because the trigger for El Nino is weakening air pressure in the western Pacific, but it's also an ocean phenomenon. So it's an interesting interaction between atmosphere and ocean. Thank you.